Okay, this lesson is on 2.1.1. We're going to start a new chapter. This chapter is focusing on angles, and so today we're going to start being introduced to some of these really important angles that we're going to see for the rest of our geometry curriculum, right? So these three are called complementary, supplementary, and vertical angles. So we're going to walk through each one of these and kind of help you see, oh, what is called supplementary, what is called complementary, and what are vertical angles. Okay, so in 2-1, if you want to read more about it in your ebook, there's a little bit of story behind it, but it is saying that Mr. Douglas says that if he made the hinge mirror, remember the mirror we used on the very first day of school, the hinge mirror, the one that got put together with a piece of duct tape with the two mirrors on the side like this, he says that if he opens his hinge mirror to a 90-degree angle, then right here, this is his hinge mirror right here, that's his mirror, and he says that as long as he looks in one way, well, never mind, the other way, as long as he looks in one way, he's going to be able to see back the same exact thing the other way. Right, so he says he can see himself no matter which direction he looks into it, because he can tilt a little bit. If he's right here, he's looking here, and he's going to see something this way back, right? So the most important thing is, all right, looking at this diagram, he is looking at the mirror. He is staring at the mirror this way, and he sees himself back this way. Very cool. But what have you noticed? What do you notice about his line of sight? So the two lines that I just emphasized, the line going this way, oops, sorry, I erased that, the line going this way and the line going this way. What do you notice about the two lines? Can you explain why his trick works? All right, so take a minute, think about it. One thing I think maybe why his trick works, he's looking in a mirror, so there's a reflection there somehow, right? So I'm guessing there's some reflection in there. Question mark. I see the two line of sight, so his eyes are looking this way, right? So my eyes are looking, well, I'm focusing on something, a focal point. But if you were to follow just your eyes, then the two eyes line of sight looks like lines that will never cross each other, which we talked about in chapter 1. So parallel lines, right? These are your guesses, right? We don't know for sure, but maybe through this lesson or through the rest of the chapter, we'll be able to have our guesses really confirmed and be like, oh, that's what it's talking about. Okay, so who knows? All right, we look at the next problem in our ebook. Again, you can follow along the book, or you can kind of listen to me talk about this. So examine the diagram of equilateral triangle ABC. So this is an equilateral triangle. I remind myself this is equilateral triangle, okay? The top of the triangle is usually referred to as angle A, written as angle A, and that is the vertex of this angle. So here as a vertex, angle A. Now notice the way I write angle is I put a little arc through it, because I don't want you to confuse that with less than, right? So if I put an arc through it, it's always an angle. Sometimes when you write really quick, it's really hard to see, oh, is this an angle versus a less than, right? A little bit of difference there. But if I put an arc through it, it's a big difference, okay? All right, now it says, the measure of angle A, the number of degrees in angle A, is written as measure, like m of angle A. So that's the measure of angle A, right? That means if angle is 23 degrees, we say measure of angle A equals 23 degrees. If the angle is 55 degrees, we write measure of angle A equals 55 degrees, okay? Since triangle ABC is equilateral, write an equation showing the relationship between its angles. So we know it's equilateral. That means all the sides are the same. We kind of did this last time where we use these little tick marks to tell me they're all the same. So what do you think could be true for all the angles if all the sides are the same, right? And so think about it a little, right? And we can say that if all sides are the same, then maybe I'm going to guess that all the angles could be the same. So one thing I could write as an equation, I could write measure of angle A could be equal to measure of angle B, could be equal to measure of angle C. And we'll talk about whether or not that's true a little bit later, okay? All right, it says part B. Audrey rotated triangle ABC around point A to form triangle A, B prime, C prime. So this is very important to see what she's talking about, or which triangle we're talking about here. So triangle she had was this triangle, A, B, C, and she tilted, right? She turned it. So let me see if I can get this to to work right, right? So she turned it, right? She tilted it, she turned it, and that's how she got her A prime, B prime, C prime, okay? So, yeah, what happened? Like, what happened? I want to turn it just a little bit more, and I want to show you it's a different one, right? So A prime, B prime, C prime. So hopefully my colors help you see the original A, B, C, and then A, B prime, C prime. Okay. She told her teammate Maria, I think the two angles at A have equal measure. Maria did not know which angle she was referring to. How many angles can you find at A? Are there more than 3? So without the colors, personally, I think it's really hard to see this picture, right? Because without the colors, they all look the same. So let me see if I can help you see this. Okay, so I don't have the colors. Look, they all kind of look like just lines, right? So for me, I can see one angle here, one angle here, one angle here. Right, so I see 3 angles here. Okay, so I'm gonna write them all out. Right, if I were to talk about the angles and be very specific, you wanna go from one endpoint to another. If I'm talking about this first angle I was talking about, it goes B to A to B prime. It's a lot easier to follow that, right? So angle B, A, B prime. The second angle, oops. The second angle I wanna talk about is the one in the middle right here. So it goes B prime to A to C. So angle B prime AC. Okay. And the third angle, I want to go from C to A to C prime. So angle C, A, C prime. Okay. Can you see more? Can we maybe take 2 of them and put it together as one? All right. So maybe we can look at this angle here and go from B to A, now to C, right? So angle BAC. Maybe I can do the same thing on the other side. I can take this middle angle and add it to the big angle, the medium-sized angle there. So that is angle B prime A, C prime. So angle B prime A, C prime. Okay, looking very good. We have 5 angles now, right? Now, do you see the last one? There's one big giant angle here going from BA to C prime. So angle BAC prime. So I use my colors to try to show you. I have all the small ones first, then I have the two combined, and I have the 3 of them combined. So I have 6 angles there at A. And how do I know that? Notice all the middle letter is all A. So that is the vertex, that is the tip of my angle there, okay? All right, so in order to be more specific, right, part C says, Maria asked Audrey to be more specific. She explained one of my angles, angle BAB prime. At the same time, she marked the 2 angles with the same marking at the right to indicate that they have the same measure. So name her other angle. Be sure to use 3 letters so there's no confusion about which angle she means. So over here, she marked 2 angles that are exactly the same. She said, I'm talking about BAB prime, right? Which other angle has the same exact marking? So follow your letters, CA to C prime. So they have the same marking, so I can say angle BAB prime is congruent, meaning they're the same as angle CAC prime. That was her second angle there. Okay. All right, so this first part, we were learning about how to talk about angles, how to name them. So we are very specific. Remember, one letter is usually not specific enough if there are multiple lines there. If there's only one angle there, you can most definitely use just one letter and say, oh, angle C or angle B, right? Like in part A here, angle C, I know what you're talking about. Angle B, I know what you're talking about, right? Angle C is right here. Angle B, I know what you're talking about. But if there's multiple lines there, you really want to be very specific and use 3 letters to name your angle so we can follow your train of thought literally and go, and follow that angle, okay? All right, so moving on to 2-3. What does this say? Now, consider a diagram on the right. Oh, sorry, I went too fast. All right. So in 2-3, it says, well, 2 angles have a certain relationship. Learning something about one of them tells you something about the other. Certain angle relationships come up often enough in geometry that they're given really special names. So here are your special names: complementary angles and supplementary angles. Okay. So 2 angles whose measure have a sum of 90 are called complementary angles. Since angle ABD, if I look over here, angle ABD, I'm following the letters, have 90 degree. Oh, there's a little box here. Very good. Angles ABC and CBD are complementary. So which angles am I talking about? Angle ABC, this angle, and angle CBD, this angle right here, must be complementary. It means they add up to 90 degrees because there are two little ones put together to make this right angle. Okay, so first thing I'm going to do is I'm going to write my formula here. Complementary angles are two angles add up to 90 degrees. Okay, next I'm going to read the problem. If measure of angle CBD, so CBD is right here, is 76 degrees, what is the measure of ABC? What is this one? Well, I have to add up to 90. So what plus 76 must equal to 90? Or what's 90 minus 76? So the measure of angle ABC must equal to 14 degrees because they have to add up to 90 degrees. Okay. All right, so what about supplementary? What's the difference? All right, so another special angle is a straight angle or one that is 180 degrees. So a straight line like this is 180 degrees, okay? If the sum of measure of two angles 180, they are called supplementary angles. So there are two angles that add up to 180 degrees, okay? So in the diagram here, this is LMN is a straight angle. So here, this is 180, right? Together is 180. Now there's no symbol to tell you 180 except the fact that it's a straight line. You see a straight line, you know it's 180, all right? So now we know parts of it. If measure of angle LMP, so LMP is right here, if that's 62 degrees, what is the measure of angle PMN? So what is this one? So what plus 62 must equal to 180? Or in other words, what's 180 minus 62? So measure of angle PMN must equal to 118 degrees, as that adds up to 180. Okay. So now you have the definition for complementary and supplementary. Sometimes I give students a little bit more a hint, right? So for me, how do I remember which one's 90, which one's 180? I remind myself that two 90s add up to 180. So if complementary is the letter C, two letter C's, two 90s add up to 180, and two letter C's make the letter S. So complementary 90, supplementary is 180, right? So hopefully that will help you. Okay, now let's explore this. It says, now consider diagram here, right? It says line AB and CD intersect at E. So you have your line AB and CD, they cross here at E, right? So my diagram here, awesome. It says if X equals 23, okay, find measure of angle AEC. So AEC is right here. So I would ask you literally to cover up your paper, block off this half, and just look at what we have here. Doesn't this look like part B, where we had a straight line and then the two angles add up? So they are supplementary. So if they're supplementary, they need to add up to 180. What's 180 minus 23? 180 minus 23 is 157, right? Okay, now let's unblock what we did here. Now it says find angle DEB. So DEB is right here. DEB is this angle here. Now we're going to block off this side because I don't want to look at that. So if you look at what we have unhighlighted, okay, that's again another straight line. It's again supplementary. So then this also must be 157 because that also makes a straight line. Okay, now how do you find the last one? Well, you can block off whatever you want. You can just, again, trying to make your 180, right? So if I were to block this off, oops, sorry. If I were to block this off and look at it and say, oh, I got 157. Now plus what to give me the 180? I need 23 degrees here. Okay, so now I have all the angles. I just need to make sure I write it out to answer my question. So the question says measure of angle AEC, that was 157. Measure of angle DEB, that was 157. Sorry about my B, it's very ugly. Measure of angle CEB, that was 23 degrees. So which angle has the same measure as angle AED? Which angle had the same measure as my 23? And if I look at my answer there, I would say angle CEB has the same measure. It was also 23 degrees, right? Okay, so it says in part E, when two lines intersect, the angle that lie on opposite sides of the intersection are called vertical angles. So the angles on opposite sides of intersecting lines. Okay, and in other words, I think it's a lot easier to look at a picture. So you want to draw a picture for yourself. Vertical angles are this pair and this pair, right? They're opposite of each other, not next door, opposite of each other. So what is so cool about them? They have the same measure. If you look at what we have in our diagram, it was 23 up here and 23 down here. It was 157 and 157 here. So they are congruent angles. They're equal. Very, very cool. Right? So we established in part D, it says angle AED and CEB are vertical angles. What was the other pair I had in my picture? Well, that would be angle AEC and angle DEB. They're the other pair of vertical angles. So anytime you have vertical angles, you should have two pairs because the lines cross each other like that and creating two pairs of relationship. Okay? All right, so now you have three vocabs that we promised we were going to define. We have complementary, supplementary, and vertical angles. So just a quick recap, complementary angles are two angles that add up to 90. They don't have to be next to each other. So that's a cool thing. If one angle's over here that's 30 degrees and another angle's all the way over here is 60 degrees, they add up to 90, they're complementary. Supplementary angles are two angles that add up to 180. So again, they could be next door or they could be really far apart. As long as they add up to 180, they are supplementary. Vertical angles, they have to be on the same line. So they have to be opposite neighbors. So it can't be super far away. So if two angles are equal, but they're not of the same intersecting lines, they're not vertical angles. They're equal, but they're not vertical angles. Okay? All right, so now that we know all that relationship, let's see what we can do. Okay, so make sure you solve the variable, but also kind of remind yourself, what did you do to solve for this, right? So if I look at this, I go, oh, I see a straight line. So that means they add up to 180. I know one of them is 152, so the other one must be 28 degrees because that adds up to 180. So what did I do? I used supplementary angle. And then I just need to write my answer. Measure of angle M and P is 28 degrees. And make sure I answer the question. Okay. Part B over here says find the measure of angle FGH. I need to find measure of FGH. Oh, so that's this angle here. I need to figure out what this angle is. I see a bunch of X's. Okay, that doesn't help. But I see some markings that are helpful. There's a marking here and a marking here. So if I remember what Ms. Chu said, if they have the same marking, that means they are the same. So the geometry tells me these are the same angles. So I can set up and say, all right, the first angle, 4x minus 5, must be the same as 3x plus 2. The geometry helps you set up the equation. Now that you have it set up, use the algebra to help you solve. All right. So what would I do? I would subtract 3x on both sides and get myself x minus 5 equals 2. And so lastly, I have 5 on both sides. I get x equals 7. But wait, that's not what I'm solving for. I'm solving for the angle. So I can plug that 7 back in here into the angle I'm looking for. So 3 times 7 plus 2 is 21 plus 2, 23. So measure of angle FGH is 23 degrees. You can do a quick check. If I check it here, I should get the same thing. 4 times 7 is 28. 28 minus 5, beautiful, 23. So our answer is correct, right? But what relationship did I use here? I didn't use any of the complementary because it didn't add up to 90. Supplementary, it didn't add up to 180. They're the same measure, but they didn't make an X. So the relationship here is just they are congruent angles. All right, they were congruent angles because they have the same sign here. So they have the same little tick marks. So I just simply say they're congruent angles. Okay, part C, this was a very common mistake I saw on a previous quiz. So the angles are next to each other, but if they don't have the same marking, you cannot say they are the same. You do see this little square here, so that makes them add up to 90 degrees. So these are complementary angles, right? So complementary angles means they add up to 90. So 2x minus 4 is one angle, x plus 7 is the other angle, and you must add them up to equal 90 degrees. That's what complementary angle means. They add up to 90. Okay, now the algebra. I combine like terms. I have 2x and one more x. That makes 3 x's. I have a negative 4 and a positive 7. That's a positive 3 equals 90. Okay, solve by subtracting 3 on both sides That gives me 3x equals 87. Pause there because I forgot my math. And divided by 3 on both sides. Divide by 3, divide by 3. I get x equals 29. Okay, now again, am I solving for x? It says find the measure of angle DBC. If I follow the letter DBC, okay, so it's this angle here. Measure of angle DBC equals x plus 7. So it's 29 plus 7, that's 36 degrees. Okay, now let's do a quick check. If I plug into the other one, 2x minus 4, that's 58 minus 4, that's 54 degrees. Wait, Miss Chu, they're not equal. They're not supposed to equal. This 54 plus the 36 should be 90, and I think it does. So our answer is correct, right? Okay, last one here says find the measure of angle LPQ. So LPQ, we're looking for this angle. Find the measure of LPN. So LPN, this other angle here. So we need to find both of those angles. Okay, first thing I'm going to do, I'm going to check out what information I have. I have an x here. I have x plus 8. Oh, so I see that they're on the same side. I'm going to block this out real quick in my mind. Right? Literally, I block it out on the screen for you. But again, in your mind, you want to block it out or use your hand to cover it up and say, oh, if I look at just these two, I see supplementary angles because they are creating a straight line. Supplementary angles. So that allows me to say x plus 28. That's my first angle. And then the second angle is x. And what supplementary says is add up to equal 180. Okay, so I'm going to go ahead and add them up. I get 2x plus 28 equals 180. Algebra says subtract 28 on both sides. So I get 2x equals 152, right? And then you divide it by 2, and you get x equals 76. Okay, so that means then this is 76 degrees. If I plug it in, 76 plus 28, that gives me 104 degrees. And again, check, right? Really quick check here. 104 and 76, oh, they add up to 180, so we're on the right track. Okay, now let's answer my question. The question says measure of angle LPQ. So measure of angle LPQ, we solved for it just now, it's 104. Measure of angle LPN. Hey, LPN is opposite of the x, so LPN is also 76. But now I use a new relationship to help me answer this question. I use the fact that they are vertical angles to solve for that because they're opposite of each other on this x. Okay, all right. I know that was a bit fast, so make sure you do go back and re-look at 2-5 here. If you can understand what happened in A, B, C, D, then you're on very good track here, okay? Take some time to read over the methods and meanings. It really further, again, defines some of the angles we're talking about, defines the complementary and the supplementary, right? Now, if you're like, wait, what about the vertical? It'll come later, I promise you. And see, it shows you that a supplementary angle and a complementary angle, they don't have to be next to each other. As long as the measurements add up to 90 or 180, they are called complementary and supplementary respectively, okay? All right, feel free to go back to the video and rewatch any of the parts that didn't make sense to you or went over too fast. And yeah, and come back with any questions you have next day, okay? All right, that's it, guys.